Okay, Mr. James, this is where we're at today. This is your fatboy 2x8. Customer states when running two-pill section stays latched. And how that works is right here. This is the input circuit. And this relay dictates if it can either run as a straight 2-pill or a straight 8-pill or a 2x8. And how that works is with this relay engaged, the RF comes in, goes up through this variable, comes out, goes in, gets amplified, comes out, RF comes back, and then depending on which way we have this relay tripped, it can go bloop directly around to this connection on the relay and allow it to go straight through. Or if we activate this switch, which puts 12 volts to this circuit here, then this keying transistor comes into play, bloop, latches this guy. So now it turns into a 2x8. So then the RF comes out, goes over here, gets split evenly. RF goes here, gets amplified in this section, comes out, gets combined in this section, passes by a capacitance, pumps it up from 100 ohms, knocks it down from 100 ohms, which is here. And we do that with a little bit of an inductor and a capacitor, and then drops it back to 50 ohms to go back to the coax. Right? Right. Okay. Or we can have this switch off, which shuts off the 12 volt to this relay. So the RF comes in, passes through, goes around, and it's a regular 8-pill. Or shut it off completely. RF comes in, goes through this relay, and then out. So if we activate just this switch, this circuit stays active, and this acts as a pass-through. We activate that switch, now this circuit becomes active and this one becomes passive. Activate this switch, this circuit's active, and so is this relay. So now this circuit's active and this is active. So this drives into this, which gets us more juice. Okay, now we got the basics laid out. Let's start up here. We're going to work our way left to right. Over here is our spectrum analyzer, 0 through 264 megahertz. Down here, we're going to start here. 1,000 watt slug and peak, 1,000 in average, 5 watt slug and reverse back from the bird, 10,000 watt dummy load. Then we're going to come up here and we got a 5 watt slug and reverse between the bench 2950. We're going to come down here and we're at 15 volts flat. Okay, so now we're going to get ourselves some bass readings. Let's make sure we're in 1x. We are 1x. So, yada yada da, da 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 da, let's make some watts. Let's zip on in here. First we're going to show you drive. This is everything off. Hello, 1, 2, our 20 whole watts. Here's our 2-pill section with the variable all the way open. 1, 2, 1, 2. 300 watts of power. 300 watts of power. Here's our 8-pill section. We're going to go to 2x, so now full deflection on the meter, otherwise the meter moving fully to the right-hand side is 2,000 watts. About 1950 and some change. Okay, that's with 25 watts worth of drive. Hello, 1, 2, 1, 2. She's got a little dirt to her, but not a lot. Nothing to get too excited about. Now let's come up here. Hello, 1, 2, 1, 2, 1, 2, 1, 2. So less a watt of reflect. Let's go take a look at just a straight 8. That was into the 2x8 configuration. Hello. 8-pill looks good. It's falling down. That means it's falling into resonance. Some more drive we put into it. And then here's just the straight 2-pill. Hello, 1, 2, 1, 2, 1, 2. Okay, so that tells us that we can pick up a little bit more watts by changing the input tune to the 8-pill section just a little bit. Change the output tune. We're going to change the whole output circuitry here, by the way. Change the output tune just a little bit on the 2-pill section. And We can change the output tune on this just a hair to compensate for the input tune that we're going to adjust, and we'll probably pick up a little bit of power. I can tell that by looking at just the reflect meter and switching between the stages. It is what it is. Okay, so now this guy wants the full Monty. Now this thing is working, but I see problems on the horizon for him. And this is all Toshiba's, by the way. You see that output tuning cap? It's about 1.5 seconds from failing. See this split? This right here? Cap is still good. It's just cracked, which means it's about 2 seconds away from going tits. It happens. It just happens. It just happens. So, first thing we're going to do is we're going to rip out all these power wires, of course. We're going to come around, we're going to change these to 5 waters, which don't help you pick up any more power, but when you do have an imbalance, they're the only thing that sits between you and you chunking your transistors. It's the only thing that allows us to absorb any imbalance inside the box are these 3 resistors in this particular configuration. This here, and this here. What do we mean by that? The 5-watt resistor controversy continues. I like the 5 watts because they look cool. I like the 5 watts because they generate more smoke. I like the 5 watts because they can absorb more imbalance energy when there's a problem. If everything in the box is running in a balanced configuration, you can use like a 1/4 watt resistor here. You have to have that resistance present to make it so that the splitter and the combiner work in a balanced 50 ohm set of circuit. Okay. Remember, the RF coming out of this transformer and the RF coming out of this transformer are exactly out of phase with each other. So they only see half the resistance value that's here as a load. Okay. So you're going to see this 100 ohm resistor, because they cancel each other out, it's only seeing 50 ohms. We don't have this here that it's a 100 ohm load, and there's no way we can put enough capacitance and have the combiner actually work in a balanced configuration without having a resistor present. If everything's in balance, nothing gets hot. The reason I like the 5-watt resistors is because when something does go wrong, 9 times out of 10 the guy doesn't have a watt meter in his mobile or in his setup, and he goes, well, I knew there was a problem, I could smell it. Which is going to generate more smoke? These little son of a bitches or the big 5-watters? Obviously the big 5-watters. So as it's smoking off though, it is absorbing the watts and the imbalance in the circuit, and it's protecting you, killing your precious Toshibas or your precious HGs. So let's say you pop 1 pill. Blue, 1 pill goes bad. So this whole 2-pill section now drops out. This section's still operating, and it's still creating half of the output that this whole circuit's designed to make. Well, now there's an imbalance at the resistor. These components don't know it until this resistor disintegrates. Once this resistor disintegrates, then it loses its 50 ohm reference, then the whole circuit falls out of whack. So if we can put a 5-watt resistor here and save ourselves, I don't know, $500 at this point, having to replace these 2 transistors, and we're only going to cook off this 1 pill, the 5 watts are worth it. The same thing here. The only thing that's really protecting you from the outside world when you have RF come back from your antenna, one of the things that this does is absorb that out of phase, out of sync RF, gets dissipated here at this resistor. That's one thing. Once again, if you have it fall out of balance, because remember, this is only rectifying something that's out of phase with this. Okay, not rectifying, but amplifying. If it falls out of imbalance, this circuit, the only thing that's standing between you and the outside world and you killing the rest of your pills is that 1 resistor. So technically, no, we don't need to use 5 watts. Technically, we could use like a 1/4 watt. 2 watts not even really necessary. 2 watts technically overkill if you want to think about it. Just saying. So it is what it is. Oh damn, look at that. A little moth stuck down in there. At least not a cockroach. Let's go ahead, we're going to shut this down, we're going to unplug it, and we're going to start ripping parts out of it. And we're going to modify it up a little bit. Good job on using the right size Anderson clip, by the way. This is the big boy Anderson clip. Not the little 150, this is a 300. Mo better. Alright. If I can get 100 more watts out of it, 200 more watts out of it by changing some little parts in here and making it run a little bit more efficiently, I have done my job. Remember, customer states doesn't seem to want to unkey when running the 2-pill section. I can't help but notice we're minusing our snub diode that sits across this pole of the relay, and there's no snub diode down there as well. So let's put some snubbing diodes in there, and I bet you that will fix that problem because it's not presenting itself here on a workbench. I sit here, and for the life of me, I can't understand why this 1,4-pill section has gotten so much hotter than this side. The copper tells the story. Look at how discolored it is. And it's just in the area of the heatsink. This one side at one point or another has gotten ridiculously hot. Meanwhile, this side that's got more transistors on it stayed cooler. So we changed a few little things in here. Obvious things are power wire and 5-watt resistors. I changed the input inductor coil to the 8-pill section. It wanted just a little bit more inductor. And a little more inductor equals a little bit less input reflag, but it equals another 150 watts on the output plus the power wire upgrade. So it's a little bit hotter. We changed out this transformer and went to a big bodied one. And we changed our tuning a little bit. I still got to lock the tube down before it leaves. But, I mean, just a couple little small things. Changed this input capacitor here on the 2-pill section. So now it's got almost a 0 input reflag. Added a snubbing diode over here on the 2-pill section on the relay. Added a snubbing diode across the output section. Although, you know, I've keyed this quite a bit while playing with it, and I gotta tell you, it's only locked up the 2-pill section once. And once I changed this capacitor, it quit doing it. Not that the input reflect was bad from the word go, it just needed a little shkamuggin in the right direction, I guess would be the best way to put it. So, I mean, added the 5-watt back here, and added metal clad capacitors here and here. We replaced, oh, Cracky McCrackhead here. I mean, this thing is, focus here, camera. This thing was on its way. It's just a matter of time. So I'm going to give credit where credit's due. This thing has got some monster fans in it. I mean, you turn a fan on this thing, there ain't no doubt that the amp is on. So we're going to save that a little bit for last. So let's start out here. And here's the radio. 2-pill section. 2 and 8. Now, if you can remember, somewhere right about in here, we had a secondary harmonic. We got that cleaned up just a little bit by changing the tune just a hair. So that's been fixed up. Now, let's go over here. And not that that little harmonic was that big of a deal. You have to remember when it comes to reading that spectrum analyzer, anything that's about, oh, I'd say 35, 40 dB down from the principal, I don't get too overly concerned with. I mean, in the ideal world, you know, where the Smurfs rule the Magic Kingdom, we want to have just one signal spike up there on that scale. And when we modulate it, nothing else goes out. Nothing. It's usually just the tube linears we get to see that kind of stuff on, and very, 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 very hyperly monobanded boxes. like just 2 or 3 frequencies. Otherwise, you're going to have just a little bit of schmutz, just a little bit of schmutz make it on all the way through. So we're down on 1X, and let's revalidate our completed test data, I guess would be the best way to put it. Hello, 1, 2, 1, 2. Same amount of drive. Here's our 2-pill section. Hello. We're seeing a little bit more power out of that 2-pill section. Just a little bit more. Hello. About 25, 30 watts. Let's go up here and let's take a look at the input reflect. Next to nothing. Next to nothing. So that means about 380 to almost 400 watts is now going into the 8-pill section. Hello. 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 Audio. Okay. We were seeing about 18 and some change, maybe 19-ish out of this thing. Hello. Now we're seeing a solid $2,000. And that's with 20 watts of drive tickling this thing. You can put a little bit more into it. Remember, it's two 2879s, not 2290s. Hello. So just polished it up. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Just polished it up a little bit. Here's the 2 driving into the 8. Okay. Now, let's come back down here. Let's knock off the 2-pill section. Go back down to 1X. And let's just kick up just on the 8. So now all we're running is a single 8-pill section. Hello, 20 watts of drive. Hello, 20 watts of drive. Hello, 20 watts of drive. Hello, 1, 2, 1, 2. Hello, 20 watts of drive. Hello. Very clean. That's with 20 watts of drive. Hello, 20 watts of drive. It's like diminishing returns, isn't it? 20 watts of drive, swinging almost $1,000. Hello. 350 watts of drive, making 2,000 watts. So we're hitting the top end of the absolute, of the absolute, of the absolute. So, in the same breath, oh, overshot it. We're at 15 flat, fluctuating to 16. That can't be right. There we go, 15 flat. Hello. 1, 2. Hello. Hello. 1, 2. Hello. 1, 2. So we're top of the morning to you. It's about as polished as we're going to get. Just knocking the birds off it a little bit. We're not getting too overly carried away, you know. Oh, look, I found 900 watts worth of power in this box. No, I'm not going to find that. Believe me when I tell you, these guys have been building amps for a hot minute. These guys have been building amps for a hot minute. Okay? Can't take nothing from them. Just kind of helping just a little bit. So, as you can tell, the fans are incredibly loud. That's good. I don't mind loud fans. You shouldn't mind loud fans. That means we are moving air. Okay? I mean, the best thing that we could do would be to cut out these fins that are on the back of this cabinet. It's got these slotted exhaust ports on the back. If we really wanted to help things, we could cut these slots out and increase the quantity of air. But, I mean, it's just a small little improvement. But Hello, 1 2 1 2 1 2 1 2 1 2. More air equals better cooling. Off. That's odd. That should kick on the fans too. Interesting. I wonder if that's even wired in. Let's check that out. Okay, so the fans are not wired into the circuitry at all. The 2-pill section just sits there and runs independently. I would have to add 3 relays. No. Yeah, I'd have to add, no, 2 relays. I'd have to add 2 relays to this, and I'll call the customer and see if he wants to have this run. I don't know if I mentioned this or not. The reason it's so shiny is because I did give it a bath. I washed all the old schmoo out of it before I did the power wire upgrade, and then I went in here and shot this with some clear. So it's all cleaned up. We're done for the most part. Now, we can't let this thing go through life naked. That's not all right. I mean, she is a little girl with the high top, high edge bikini going on with most of her butt cheeks hanging out. I guess that's the thing that's in now, is, you know, everything short of a G-string bikini. But we'll put some tassels on her. Just like that. Well, gentlemen, on that note, I'm going to call this one a win and get this one turned around and headed back home. It doesn't need to be here anymore. Everything checks out. All the little modifications the customer wanted to have done are done. That means our time, you, me, everybody else involved, our time together has come to an end. Appreciate everybody tuning in to watch this. I think what's up next is a black-faced, no, I lied. I was going to say black-faced Sweet 16 new style box, but what's up next is a 3-made. My buddy 3, I like him. He's a good guy. Honest, tries hard, works hard, makes a beautiful looking amp. Kind of interested to get inside of one. I haven't been in one now for 3 years? 2-3 years? And the last time I was in one, he was still very much in the learning process. But then again, let's face it, gentlemen. None of us ever leave the learning process. And if you get to the point where you think you know it all, or you brag to everybody, I've been there, done that, long time before underwear was made, kind of thing, you need to quit. It's time for you to stop, go do other shit, because I found in radio, honestly, in radio, you never know it all. Never know it all. And if you find yourself hooping and hollering or screaming at somebody on the phone claiming that you know more than they do, it's also time for you to quit. That's why I enjoy telling people, hey, I don't think that's going to work for you, but I want to help you build it, and I want to learn what you're going to teach yourself as you go and build this. Got a friend of mine, got a big antenna project he's getting ready to put up, and I told him the other night on the phone, I said, man, I don't know if that's going to work or not, but in the same breath, I want to help you build it. Because what is the product of learning? It is trying things that are not within your knowledge base or outside your comfort zone and getting to learn from them. There's nothing wrong with that. That's called life. That's not doubting or hating on somebody. That's called wanting to learn and the desire to learn and teach yourself more. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. I do this because I like the companies, not because they pay me to. I say, thank you, MacMan. Thank you, Siglent. Thank you, Excess Power. Thank you, Bird. Thank you, Coaxial Dynamics. And thanks to every single one of you. I mean that sincerely from the bottom of my heart. Now, I'm going to be on a little bit of a tear the next couple days. You're probably going to see one YouTube video from me every day, if not maybe 2. They're going to be short, sweet, and to the point, just like this one. I'm not going to lie. I got some big shoes I got to go fill. I got some big missions that I got to go take on. I got a lot of stuff I got to get going. And I need to get a bunch of projects wrapped up in a short amount of time. So hold on, Alice. We're going to go down that rabbit hole.